Hi guys, we're jumping ahead here to the next chapter. If you're on book 7, it's chapter 3. We're on page 97. Otherwise, look at the title. We're looking at tangents is our topic here. We'll start off with this question 3. Find the equation of the tangent to this curve at the point x equals 2. Point where x equals 2. So this curve is x squared minus 6x. If you factorize that, you see x and x minus 6 is factors, which means 0 and 6 are roots, 6 and 0. U-shaped curve because it's an x squared, positive x squared quadratic. And the point that we're talking about, when x is 2, y will be minus 8. So 2 minus 8 is the point. Find the slope of this tangent line, and the equation of this tangent line is what they're asking for. Well, the slope is just the derivative, or at least the slope function. So, sorry, I've got that down here. F of x is x squared minus 6x. F prime of x is 2x minus 6. 2x minus 6 is a slope function. That is, at any point x, so if x is 3, it's 2 times 3 minus 6 is 0. At x is 4, it's 2 times 4 minus 6 is 2. At x is 2, it's 2 times 2 minus 6, which is negative 2 as the slope of that line. Now, they've asked you for the equation of the line. So you'll say, well, that's x1 and that's y1, and the slope is minus 2. So y minus y1 is m times x minus x1. That'll give us y plus 8 is minus 2x plus 4, or y is minus 2x minus 4. Okay, so you can see I haven't drawn that too perfectly. It should be going through minus 4. If you have GeoGebra at home, I'd very much encourage you to put that function into GeoGebra and this line into GeoGebra, and you should see that they're tangents. Question 9 says, find the coordinates of the points on the curve, this cubic curve here, at which the slope of the tangent is 0. So here's a cubic curve. The tangent on that line, and I'm after losing my ruler, unfortunately, okay. The tangent on that line at any given point, you can see here or here, but if you want the tangent to be 0, that happens up here. That's where the tangent is 0. That's called a turning point, and down here as well at a turning point. So you're actually going to find 2 points on a cubic where the tangent line has a slope 0. So let's find our slope function. dy dx is 3x squared minus 12. And we want that to equal 0. So we say 3x squared minus 12 needs to equal 0, which means x squared minus 4 equals 0. That's dividing through by 3. X squared is 4, and x is plus 2 or minus 2. Okay, so that's minus 2 there, and that's plus 2. Sorry, that's not the x-axis, but those are the x-coordinates. What's the y-coordinate? Well, if x is plus 2, y is going to be 2 cubed minus 12 times 2 plus 4, that is 8, plus 4 is 12, take away 24, that's minus 12. So one of our points is 2 minus 12, and our other point is going to be when x is minus 2. So y is minus 2 cubed minus 12 times minus 2 plus 4. That's going to be minus 8 plus 24 plus 4. So what's that going to be? 28 take away, that's 20. So minus 2, 20. So that's this curve. This point up here is minus 2, 20. This point down here is 2 minus 12. Those are the 2 points at which tangents to the curve will have a slope of 0. The next question we're looking at is this question here, question 15. Sarah throws a stone horizontally from a point on the top of a 500-meter cliff. The equation of the path of the stone is given by this function here. How far out to sea does the stone reach? Now that's nothing to do with calculus, that's just algebra, when is the y coordinate going to be minus 500? So we take our function, we say the y is going to be minus 500 is minus x squared over 125. Multiply through, you get minus 500 times 125 is 62500, needs to be minus x squared. So x squared is 62500, positive 62500, and then you can take a square root. And 250 meters out to sea, that's where that happens. Okay, that's where you're at minus 500. And the second part of the question says tan theta is the slope of the curve at this point. Okay, so at this point, the slope of our tangent line is tan theta. Find the angle at which the stone enters the water. So find the angle that you strike the water at. This angle here, theta, which is the same as this angle up here. Okay, those are called corresponding angles. And you can find that by saying, well, that's the opposite over the adjacent is the same as the rise over the run. So tan theta is the same as the slope. Okay, so we're really saying what's the slope at 250? Tan theta is, well, the slope of this function is minus 2x over 125 at any point along the function, but particularly at x equals 250, that's minus 2 times 250 over 125, and that's going to be minus 4. Okay, which means theta is the inverse tan of minus 4. Now, because we want the acute angle, I could probably just take tan of plus 4. But anyway, let's have a look. Inverse tan of negative 4 is, well, negative 75. And we're going to find it 75. How do I explain negative 75? Let's just say it's 75.96. Okay, and you could have just as easily said opposite over adjacent is going to be 4 over 1. The minus tells you what way the line is going. So tan inverse of 4 is the same value with a positive number. So that's the angle that it strikes the water at, which is what we were asked. In question 16, what is the sign of dy dx when a curve is increasing or decreasing? So if here's a curve, if the curve is decreasing, it means as you move left to right, you're moving down. So down as far as here, any tangent line I might draw has a negative slope. Whereas once I get past this point, the lowest point where the slope is 0, at every point after that, if I draw a tangent line, the slope is going to be positive. Okay, so the answer is when we are 1 increasing, dy dx is greater than 0. And when we are decreasing, dy dx is less than 0. That's from here, part 2. Part 1, when we're increasing. So question A says, if y is x squared minus x minus 6, find the interval for which these functions is decreasing. Okay, well that's decreasing when dy dx, if it's decreasing, dy dx is going to be less than 0. So that is 2x minus 1 is going to be less than 0, 2x is going to be less than 1, and x is going to be less than a half. So there's the interval where this function is decreasing. Now, that makes sense. U-shaped quadratic up as far as 1/2 on the x-axis, the function decreases. That's fine for every x value before that. For this one, it's a cubic, so we're actually going to find that we've got 2 numbers for which the function is decreasing, and it's going to be decreasing between these 2 numbers. So let's see what we get. Dy dx is going to be 3x squared plus 12x. Okay, 2 disappears. And we want that to be decreasing, less than 0, which means x squared plus 4x needs to be less than 0. It's dividing across by 3. Okay, well that is a quadratic function with roots at 0, at -4 and at 0. And if we want that to be less than 0, the answer is x has to be somewhere along here between -4 and 0. That's where the function is less than 0. So 0, -4, there is our set of values for x for which this function is decreasing. Okay, so between -4 and 0. Now, can I ask you please now to try questions 1, 4 and 17. Take this down for classwork. It's a bit ambitious. It might be more than one class, but let's try questions 2, 5, 6, 7, 8, 10 to 14 and 18 to 24. That might take us more than one class, like I say. Okay, see you next time, guys. Bye bye.